Welcome to Emilak Online Tutorial. Before us is this question in physics that says that two bodies X and Y of masses 5.0 kilogram and 7.5 kilogram respectively are connected by a light inextensible string as illustrated in the diagram below, which is this. If X is placed on a rough surface, so this is X, and automatically this is Y. So which means this is 5 kilogram and this is 7.5 kilogram. Now, rough surface of coefficient of static friction. So which means that the coefficient of static friction is 0.5. Now calculate the normal reaction. Alright, let's take note that this is the frictional force here. That is the force acting against the motion, and the normal reaction, which is R. So for normal reaction, we have that R equals to mg, which gives us for this on X. So we have 5 times 10. So our normal reaction here now might be 50 Newton. Okay. Now we're now to calculate the frictional force. All right, and we know that the frictional force, which is this. All right, the frictional force is this. All right, and our coefficient of static friction is given as 0.5 times the reaction, which is 50. So here we are that converting this to fraction, this will be 5 over 10 times 50. This 0 cancel this 0. 5 times 5. So our frictional force will give us 25 Newton. Alright, so we are told to calculate for the string, the tension in the string. Alright, now looking at this is more massive than this. Automatically, this body will actually move towards the right hand side. Take note the weight here. Alright, so the tension will come over like this. Okay, alright, so there's a tension here and there's also a tension here. Take note, both tension are the same. Alright, so now let us take note. Okay, let me just quickly utilize this place to solve. Now let us take note that F equals what? Mass. That is the product of mass and acceleration. And take note that for the body to move, this will happen. Alright, now for this here, tension, for this body to move towards the side, definitely means that this tension is greater than the frictional force. So here we know that the tension minus the frictional force equals mg. Okay, now still using this law here. Now for this to move here, it means that this weight will pull this down. So which means this weight here greater than this. So here we have that the weight of this, okay, let us say of y, minus the tension will give us this. Alright, so take note, it is the force equals to what? Mass times acceleration. So the force here is this minus this, and the total force here is the weight minus this tension. Alright, now this is equation 1 and this is equation what? 2. Alright, so with this now, since we are looking for tension, okay, this is M1 and M2 because this mass is here and this mass is different from this one. Okay, so here we can now say the tension then minus this frictional force, and frictional force is given at 25 equals M1 is 5A, right? Okay, Now this one, take note that the weight here, that will be the product of the mass and acceleration due to gravity. So, and the mass here is 7.5. So for this one here, we have 7.5 times 10. So this one is, let me put it here, 7.5 times 10 will give us 75. Alright, so here we have, for the second equation, 75 minus the tension equals 7.5, product of 7.5 and the acceleration. Okay, so with this now, we can let's change this equation. So here we can have it to be making t the sort of formula here from equation 1. We can say that t equals to 5a then plus 25. Now putting t into this equation, you have 75 then minus 5a plus 25 then equals 7.5a. So we are putting this into this. So here we now have that 75 minus 5a minus 25a. This minus will affect this minus because you're opening bracket, and equals to 7.5a. Alright, we can now collect like terms. Now you have 75 minus 25. Now this will move to the right side, to the left, to the right hand side. So here you have 7.5a now plus 5a. So and as such, this will give us 50, then equals here you have 12.5a. Alright, so we can actually divide both sides by 12.5a. This will now cancel this. So our a will now be 50 divided by 12.5. Now this should give us 4 meter per second square. So since we've gotten this, you can now input a into either of this equation here. Alright, so from the first equation, which is t minus 25 and equals to 5a, now replacing a for 4, you have t minus 25 equals 5 times 4. So here you have t minus 25 equals 20. Now subtracting, adding 25 to both sides, plus 25 equals to plus 25. So here we know that t, this one will give us 0, equals 45 Newton. Final answer. If you love what I've just done, please kindly subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos in physics, chemistry, and mathematics. Thank you and God bless you.